How many people they believe that they have a balanced file system in their HPC, I mean, computing system? Raise your hand, please. I mean, nobody. So, I mean, balancing system, I mean, HPC supercomputing system consists of different things, actually. We start computing, network, storage, and to avoid complaining of the software people, also software. So we have actually four major points that we need and say this is our HPC system. And usually people put a lot of computing and they will try to save a lot of money in the storage. Sorry. Actually, if you have a problem, at any level there, your system will get unbalanced and you will have a real problem. So balancing it is one, I believe it's fundamental, and just trying to maintaining the balance of the system in every upgrade is essential. So we'll be just talking, I will be here mentioning a couple of points, 4 or 5 points, and each one will just be hitting an issue just with the storage system in HPC supercomputing. Maintaining a system, you know, when it means balance, that means we have to grow it and just to keep the capacity that will be handling the computing. You know, and with growing, with the technology that we have today, that means growing a big system that will make it very, very difficult to maintain the reliability there. You know, tons of disks, I mean, a lot of controllers, a lot of failures of the hardware, and maintaining that would be very difficult and challenging. You know, yesterday we talked about metadata and dealing with metadata, and this is an issue. Thanks a lot, I need that really. So I mentioned metadata, and this is a big problem. So I gave an example. You know, one of our users was producing 27 million files in one simulation. I mean, you know, we need to deal with such cases. It's wrong, it's right, you know, but it's available and we need to deal with that. Now, I'm mentioning all these problems and this challenging point to the community because here we have 4 vendors and 1 client. And I'm the client, I'm going to be the troublemaker. So I'm going to drop the ball here for all these kind of problems, and I would like to have experts to answer, at least to see what's their vision in answering these questions. And I still have 2 points actually. One of them concerning the RAID. We believe RAID is dead. Whatever it is, 5, 6, whatever it is, there is no future. I mean, we have to wait 2 to 3 days to rebuild 2 terabyte disk. What will happen if it is 16 terabyte? I mean, how many days we have to wait? We know that, you know, we'll have bad blocks, super blocks, and every time just rebuilding, we are getting all the data from the rest of the disk. And if we have any problem during the rebuild, that will cause a different problem. And if our RAID is dead, I lost my data. So RAID, the concept of the RAID, if it's 5 or 6, and now I believe that 7 is available, you can lose 30% of the capacity just for the RAID 7. So it's the wrong approach, and we believe it's dead. So alternative, declustering, we hear like, since 2 or 3 years, we are talking about declustering, but we did not see yet anything. And finally, software. You know, all the community here, we have a community that believes in open source. And, you know, GPFS is nice and is very mature, and we like the software. We have seen that FA-GFS is coming out also just, it's easy to use, to implement. I implemented myself. But open source should survive. We need an open source HPC file system that could be for the benefits of all the community. So these are my words. These are what I wanted, the points I would like to share. And that brings us to the point where future of Lustre and how WAM Cloud and the rest of the community will be dealing with open source. Thank you. Maybe Brent?
Sure. Do you want to pull up that scale slide? Do you think we would find that? So I have just one slide, which is, oh, here it is, page down. Yeah, so here, let's just set some context for what the National Labs guys are predicting, although I would say that already that 2018 date is slipping. But, so they want to get to exascale, and that means, you know, 300 to 300 petabytes of main memory. A file system which is, you know, 100 to 9,000 petabytes, bandwidth of 12 to 1,000 terabytes a second. So if you do the math, this is like, you know, 20,000 disks will get you the capacity, and 160,000 disks would get you the bandwidth they're looking for. So that's just nutty, right? That's just wacky. So there's some unknown problems that we have to solve. The other way I look at it is if you have a storage server, say that has 32 disks, and it does 6 gigabytes a second, so 1,000 of those would give you your 6 terabytes a second, which is the midpoint there if you look at that top line. And then a little bit later, then that's if you double the speed of the storage server, so it's or quadruple it to 24 gigabytes a second, have 64 disks, you need like 2,500 of them. So that's just gives you an idea of the scale. Today, for example, the largest Panasas system is 1,000 storage servers that have 2 disk drives, and they're, whatever, they're 150 megabyte per second little dinky guys. So that's just to set your scale. I wanted to address two points. So for RAID and declustering, I mentioned this yesterday. So Panasas does per file RAID instead of per disk RAID, and we decluster the parity groups across the storage devices, so we get rebuilds of high capacity storage blades in like under an hour instead of days. But I also said that you need to do that for reliability reasons. I agree fully about the balance statement. I do believe that customers have realized over the past few years that they need to spend more money on storage. We're seeing that. Internally, the Panasas system has a very balanced approach. The little storage, it seems wacky to have a storage building block, which is 2 drives, but 2 drives, a processor, memory, network interface means that as you scale capacity, you scale performance. I still think we have the best performance on a per disk basis compared to any other hardware platform. And in terms of open source, I agree and I disagree. We've been working hard on the parallel NFS standard so that we can have an open client that works with a lot of different file systems. I do think that having a server that is reliable and performant and good data integrity is something that vendors will be providing, because frankly, it's hard and it's really boring to fix all the hard bugs and corner cases. And unless you have the resources and motivation and customer base to go fix all those hard bugs, I don't think that the open source community is going to do it. That's my contrarian view. But at any rate, so that's my two seconds.
So what was the question again? So, I mean, from our point of view, being working for one of the major OEM storage vendors, 160,000 disks sound fine to me. I don't have a problem with that. If we can just get enough throughput out of those disks, I still don't have a problem with that. That said, 100,000 or 160,000 disks is, it's a couple of 100 metric tons, right? We need to, get that stored somewhere. So I agree to a certain degree that, disks might not be able to do it. However, what is the alternative to disks? Is it, flash? Well, we had a prediction that flash about this time frame would be about the same cost as disk on a gigabyte point of view, and that has not actually panned out, and it actually looks like it may never pan out. So, flash is not the answer either. We've always said that the cheapest storage that you can have is tape. Honestly, tape seems kind of dead. Not from not dead yet. Not dead yet. No, I know that. But from a performance point of view, I mean, we're getting to a point where we cannot really have enough bandwidth in a tape library to be an equal part of a storage file system. Yes, we can build an HSM solution. Yes, we can have everything automated, but it still means that as soon as you touch a file which is on tape in your 5 exabyte tape library thingy somewhere, it's still going to take you an hour to get it back, at least, with the file sizes. So, patience is not something that this crowd is known for. Not at all. So, I still think that disks will, unfortunately, be something we'll be faced with. What can we do to speed things up? I still believe in multi-tier storage within the enclosure. Not necessarily adding, SAS drives, SSDs to your SAS enclosure just to get a tier there. But, I would foresee developments, even though, and I'm not predicting anything that we're doing at Xyratex or anything at all, because I'm definitely not on the need-to-know basis for these things. But I would imagine that we start seeing disk drives with multi-tier architecture within the actual drive. Let's say we add a gigabyte of RAM to each drive to be able to cache some things, keep the bitmaps, for instance. That means rebuilds could be faster. Having a flash layer in between to actually be able to stagger large reads and writes at the same time. So I think that the disk drive per se will morph into a system-type environment with more logic on it. Is there any reason why we can't add a full CPU to each disk drive to do integrity tests and other things to actually make it self-repairing? I see no reason why not. It's just a question that, nobody's really taken that step yet, because disks have worked for so long and it's so simple getting it up and running. And, we have reliable SAS protocols today that will become faster and faster and faster. But honestly, in order for this revolution to actually happen, there's two things I pretty much require to see. One is storage has to become an equal player in the data center. It's not an add-on to your compute. It's not something that you do as an afterthought. It has to be an equal partner of your compute system. Whether it's part of the same rack or you mix a storage rack with a compute rack, but it has to be an equal partner both on the fabric level and from a power and cooling level. That's one of the things I need to see out there. The second thing I need to see, and we already touched about that, is file systems. Now, whether that file system is PNFS or if it's Lustre, which would obviously be one of my choices, mainly considering between Andreas and myself, we represent 99% of the Lustre community at the moment from a development point of view. But I'll let him address that because he doesn't have the hardware, just have the software. But I think that's a good way forward. It's been proven to actually work. There is a lot of community effort. Has it suffered for the last year? Yes. But I think that we actually pick up speeds. Are there things on the horizon that will take it to the next level? Definitely. There's probably too many choices out there. But we need a vocal user group out there to actually figure out which of the future features that we see in file system is an important one. Is it just accessibility, which PNFS will solve? Is it other things that actually comes into having a full ILM file system, even though it happen to be an extreme high-performance file system? That's something that I'll let Andreas answer.
Yeah, so I think it's important to address the one question about open source and Lustre. As many of you probably know about Oracle and their decision to essentially cease development of Lustre has caused a great deal of concern in the community. But I think an important thing to note is that the existence of WAM Cloud and Xyratex working on Lustre today is essentially proof positive that open source works, right? If Lustre was a closed source, proprietary file system, and the company owning it decided to stop selling that product, your data would be locked in an obsolete system. You wouldn't be able to move forward with using your file system, getting support, being able to upgrade. And WAM Cloud is working hard with a number of vendors to make a new release of Lustre version 2.1 by this summer. And the roadmap of Lustre is looking as good or better than it has in the last few years. Quite a number of customers are interested in funding development for Lustre, and we're of course interested in doing that development and bringing it back on track after a sort of a hiatus of the last year or so. In terms of future growth and capabilities, I think the roadmap up here is pretty familiar to me as well. We've been working with the national labs, to develop capabilities within Lustre to meet, this kind of roadmap. At least the 2014 is achievable, I think, with Lustre, and it's not a giant stretch at this point. 2018 is looking more scary, definitely. I think to Torben's comment about CPUs and smarts and hybrid storage built into the disk. I mean, that's one of the things that Lustre is very good at, is that it already has CPUs in the disks. They're gigantic disks. I mean, years and years ago we were looking at essentially object-based storage at the micro scale. It would be one disk with an object-based interface, and that really didn't pan out. There's too much low margin there, too much overhead, and so Lustre has really progressed to the point where the object-based disks are really gigantic, maximally scaled components. Your OSTs are, top of the line. RAID enclosures themselves, they have high-end systems in front of them with high bandwidth networking, and that really allows you to minimize the management overhead and maximize the performance of your interconnect. You don't want 100,000 IB ports on your network just to attach all the disks, right? You need to leverage that at a very high level, and that's the direction that Lustre has gone, is aggregating all of the complexity into one big box. Can't remember if there's other points. I'll pass it on. Thanks.
Thanks. So regarding the topic of open source, I'm excited and happy to see that we have more companies today and more organizations today looking at developing Lustre. If we looked at the industry a year and a half ago, we wouldn't see this many resources being allocated and being dedicated to developing and furthering Lustre. So I'm pretty optimistic and excited about the future that we are going to see additional improvements and features added to Lustre. I'm also happy to see PNFS coming along, and I think it's going to play an important role in standardizing how we parallelize NFS and how we access these different scalable NFS infrastructures. And that's also good for us, the vendors, because it gives our customers a standardized way to access our products and allows us to differentiate our products in the back end, basically, based on how we place the data, how we manage the data. In terms of the management of data, I think we need to do more in intelligent data management. Part of what I mentioned yesterday was building a modular I/O subsystem so that you can scale capacity and performance independent of each other. The way that would work is with intelligent data management that allows moving of data based on user-defined policies. HSM is not a new concept. It's been around for a long time, but I think we need to do more integration with HPC file systems and some of those existing technologies to allow that functionality to be used in our HPC clusters. The other concept that we should also be open-minded about is leveraging technologies and techniques that are being developed in the commercial space in HPC. Typically, it's been the other way around. HPC has been the bleeding edge. Technologies that have been incubated in HPC space have found their places in enterprise and commercial computing. But I think the opposite should be true as well. We can look at how we use maybe dedupe and compression in HPC to not rely on tapes, but maybe rely on some level of compression to get a better, more efficient capacity out of our disks, out of our spinning disks. Other technologies that we can look at are virtualization technology, since it has an performance overhead, hasn't been used extensively in HPC, but that overhead is slowly decreasing. So maybe we can look at how we create virtualized appliances to be deployed at different places in our HPC clusters. The other concept that I think we should consider is Dr. Panda talked about how they optimize MPI based on the architecture of the system, the NUMA functionality that exists, the NUMA characteristics that exists in the system. We need to pay more attention to that in our storage access patterns as well, because the servers are not going to get simplified. They are becoming more and more complex in terms of their core and process architecture. So we need to pay attention to which process does I/O, how the I/O-intensive processes are mapped into the system. So more intelligent placement of processes with I/O bandwidth and I/O latencies in mind is also an important concept.
I believe that some of the answers just were convincing for me, and some of them were not. I will leave this judgment, for everybody. But before I just keep hammering the storage people, I would like move it to the network guys. And I think that the network as attached, storage depends a lot on the network if we want to scale. And we know that latency is, as bandwidth, is very important for the storage. We know SAS is doing very well at the latency part, but I don't know how much the InfiniBand, because it's pretty challenging there. It could be, delivering the same latency. And I would like this question to address it. Maybe Gilad, maybe Ares, just to see what we could really improve from the InfiniBand point of view to address any problem with storage that came from latency issues or bandwidth or any problem at the network level, and how we're going to move in the future for improving that concept.
So from InfiniBand perspective, and I'll talk from the technology side of things. InfiniBand, as we all know, or most of us know, started as a 10 gigabit per second network in 2002. And since then, it's doubled its speed every 2-3 years. All right, so it moved to 20 gig. Right now, it's 40 gig. This year, we expect to start saying the next generation of InfiniBand goes to 56 gigabit per second per port. And probably, 2012, 2013 timeframe. It's going to go to the 100 gigabit per second per port. But the more important part is from the InfiniBand perspective, I think the speed of the network from the throughput, it's higher than the PCI Express one. So from the server perspective or the client perspective, the PCI Express is the limitation factor, and the bandwidth that InfiniBand provides match more than what you can put on a server. So that's going to provide it. Right, from what you can do. From a latency perspective, same as it went with the bandwidth. When InfiniBand started latency, it was PCI X device, I think like 5 microsecond latency back then in 2002. And then again, like the throughput latency also was being cut down. And if you look on RDMA latency, memory to memory, it's in the range of 0.9, even getting a bit lower of microseconds. So we're talking about 900 nanoseconds for RDMA. If you look on latency within the server, let's assume that you don't have storage outside and all the storage is on the local disk that exists in the server. Latency within the server is in a range of 300, 400 nanoseconds when you go through the PCI Express. So latency outside of the networks is becoming the same order of magnitude as the latency within the box. So the capabilities from latencies and throughput are there. And the nice part with InfiniBand, compared to other options, is that InfiniBand doesn't have all the heavy load of backward compatibility with things that were designed 20 years ago. And that's why you can really go and speed for throughput and reducing latency very nice every 2-3 years with a new generation. Now, the big component here is not what InfiniBand can deliver from a performance perspective, is what's the way that you run the software layers on top of it. And this is where you go in through all the overheads and stuff like that, right? If you have very fast drivers or storage protocols that's run on top of InfiniBand, which is nearly running on top of bare metal, then you get the throughput and latencies. If you create heavy drivers and complex protocols, then you kill all the benefit that the network can give you, the storage can give you in the software. So at the end of the day, we're talking about the hardware and speeds and stuff like that. At the end of the day, the software is the most important part. So you said that, there is element of networking and servers and storage. At the end of the day, the software makes it everything, right? And this is where most of the collaboration is supposed to, or it's already being done, but this is where collaborations are happening on the software side, right? We're talking about Lustre, and you see the collaboration there. And more collaborations will happen. And definitely if you want to reach at some point of time to performance that is desired, then definitely this is where most of the collaborations need to happen between the vendors. Hopefully I answered the question.
Your answer was clear, actually. Just InfiniBand is perfect, and you need to prove different things. Thank you. So, no, I agree mention the point you mentioned, latency, and also I just, I know that there are some protocols that we use in InfiniBand to be able to access devices, and this could be just some improvement at this level also. So just different aspects. I think it's always a collaboration between storage and network just to reaching the destiny. These are the points at the moment. I don't know if you have any other points you would like to address. Very happy just taking questions.
Yes. Two questions. I want to raise one more point, but sorry, it's all about fault handling, right? To get scale, we can talk about performance and latency and bandwidth, but the only way to build a system like that is to have a highly resilient system, and I don't think I made that point well enough. Like InfiniBand, what are we doing about multipath failover in the fabric, right? So they can drop a cable and you don't abort the MPI app because that's transparently handled. You're going to have to be willing to give up some performance to get that resiliency. And I think we're going to have to look at that all the way up and down the stack. So what's the file system going to have to do to deal with failure? We already talked about the limitations of block RAID, but it happens at every layer, from the way the services do failover to the way the system manages itself, the way the hardware components handle failure. So to me, the big barrier to getting to that slide up there is extremely sophisticated fault handling on the part of the system, and it's both a hardware software issue. Anyway, I've said enough.
I'd like to get your comments on automatic file migration, which I think is the key for having
How you do?
This exactly could answer Torben here, just when he mentioned that, tapes maybe are dead, actually. Just, combination between disks and tapes could be fundamental here for different storage. And depends on the bandwidth I need. I can just drop the data in a certain type of policy. on tapes, or keep it on disk, on a fast one or in a slow one. And here the software, I think, it just could be the best controlling of such kind of data, which just could be moving things between different kind of hardware. I think there's another question. I think this is good for the software people.
Yes, maybe.
So to repeat the question, the first question was, do we need to stay with Posix as we scale up the systems and keep the same semantics between the application and the storage? And that's definitely a question that a number of people have been asking us. I mean, Lustre itself, in the file system interface to the kernel is Posix because that's the application interface that the kernel exposes. I mean, the backend storage doesn't itself have Posix semantics, and it's only a discussion point these days. But there's definitely an interest to export non-Posix interfaces that have some kind of very complex internal layout, and only in rare cases do you need to serialize that into some Posix type single stream file for applications to be able to access blobs and do I/O to the file system in an order that pleases the application is really going to be necessary to overcome the barriers and extra locking that's being imposed by maintaining Posix semantics. And there's a step beyond that to have things like intelligent storage, where you can have sort of Hadoop-like semantics where computation goes to where the storage is running, or the file is located, and operates on data as locally as it can, rather than moving the data to the compute. But for us at least, that's discussion phase, but definitely something we're interested in investigating.
If I may also add, I think over so many years, applications have been developed assuming Posix compliance. So we cannot just light switch and move to a non-Posix compliant environment in a short amount of time. But I think it's important for file systems and I/O subsystems to provide that option to the user as an option for new applications that are being developed, for application developers that fully understand the implications of non-Posix compliance, to design and develop applications specifically for that interface. So I think it should be an option, but probably not by default removing Posix compliance. Similar to the Fortran discussion that was brought up yesterday, there are so many codes developed with that assumption that we can't do away with it in a short amount of time. I'd also like to add a couple more points to the previous question that was asked. I think the technology exists today. There are many HSM tools that have a policy engine associated with them that lets administrators define migration policies based on file size, file creation date, or file modification date, so on and so forth. Then it lets users leave what we call stubs in the original file system, so that you don't have to look for the data and find out where it is. When you do an LS, it almost looks as if the file is there, but it's actually migrated elsewhere. So the technology exists. I think what needs to happen is more integration with HPC file systems.
Oh, you had another question?
So I will make one comment here, actually. Flux, Brent, he was very happy about it, and he started putting his hands for you. But open source, I believe, is fundamental for us because we would like to have the ideas of all the community and building, making applications. Even the vendors will be taking ideas from the community. And if we stop open source, you'll be ending up only living with the ideas of the vendors, and that will be just a hit for the technology itself. So, with a big community, with the open source one, we found the years and years that development in software and in storage itself has been a lot of things came from the community and helped the vendors themselves in improving their products. So you want to close Lustre and make it not an open source, so we'll have a competition.
He didn't say that actually.
What you go now with a monolithic thing,
Well, so, I mean, there's two different ways to look at it. One is that, I mean, there is competition among Lustre vendors, right? I mean, Xyratex, maybe, and, DDN, Terrascala, Dell, HP. There's a number of vendors that are selling Lustre-based solutions, right? And so, granted, yes, there aren't multiple implementations of the code itself, but if the code is freely available to everybody, there is innovation in the code, by a number of parties. There's innovations in the management. There's innovations in features that are being implemented. I mean, I don't think, in some senses, having a spec that codifies the exact implementation today is a straitjacket for future innovation. Right, and I think what you want is actually possible today, and is happening today. There is competition.
And I would also add to that. I mean, there might not be so much competition within the Lustre EU space, but Lustre isn't the only parallel file system out there. And that's a competition in itself. Just because it's become the dominant one, at least for the last top 500 lists that's been out there, may just be because it happens to be the best implementation at this point in time. There's nothing saying that there isn't anything around the corner or any of the new ones that won't overtake Lustre in a year or 2 years. That's competition in itself, and that's something that also makes us add more effort into the process, because similar to the commercial business, once you have a leading position, you don't really want to give it up, not freely anyway. So we're going to fight back from a Lustre community point of view of everything and anything out there that comes. But you're right, there is competition, and we're definitely not sleeping on our laurels here. So I was I'm not sure I quite understand your criticism of us here. I mean, it's.
Whoops. Yeah, there's competition. I think the big three are GPFS, Lustre, and Panasas, in my perspective. Although we're, any rate, but let's ask a couple hard questions. So, for example, if I want to upgrade from Lustre 1.8 to 2.0, do I have to reformat my storage? If I want to upgrade from 1.8 to 2.0 and then it doesn't go so well and I want to downgrade, can I do that? Those are some of the hard things that commercial vendors tend to want to do for their customers. Just an example. Again, my theme is there's hard problems out there, and sometimes they're just no fun to solve. In terms of HSM, I think that higher level, what the community is going to do is that they're going to insulate themselves away from the file system. So there's systems like iRods and other systems where they do data management systems that know that they're going to outlive the underlying file systems, and they're just going to invent their own data management scheme. And so it's in the file systems guy's best interest to figure out how to best support and integrate those. In terms of POSIX, there is a fine alternative. It's called MPI-IO. It's a way to specify I/O for collective parallel jobs. Everybody should learn about that. The more we do MPI-IO, the better structured the applications will be, and the more optimizations that people will be able to use for those. And you'll never get away from the dumb user that creates 27 million files as part of their. That's what users do, unfortunately. Yeah, and in terms of standards, Panasas worked hard on the OSD standard. It's not clear that that's a successful standard yet at all. We've been working hard on the PNFS standard. That has more traction with more vendors. Standards are good. They're very good for the industry. They're good for the vendors, and they're good for the customers. So. At any rate, standards are a good thing. Good for InfiniBand, good for Ethernet. So I think we should try hard for that. That's it. And I think in terms of making the other point that came up, making drives more complicated and fancy. I don't think the market is going to support that. I think it's going to have to be more the bigger building block, like Andreas said, where you build a more sophisticated storage building block out of commodity components.
I think we had one question here.
You already touched on the resiliency.
Simple enough answer.
Yeah. Wrap up.
Oh, that's through power. Yeah. There's I think there's some unsolved aspects of that equation up there. They also talk about power. They have a power budget. I can't remember what it is. It's in the 10 to 20 megawatts or something. They're only going to be able to build a couple of those machines. They're so big. Yeah.
Is there any more questions? So we are on time. Oh, yeah.
Yeah.
If you Google for the following phrase,
So could you? I did not hear.
Storage is computing.
storage
Is-
is computing. If you Google for it,
Yeah.
it does 0 hits. Why?
Experts.
Something fundamentally wrong. Maybe we need another HPC.
Yes, this is Gilad, it's for you actually, just to work on this and try to.
We do plan to extend the storage.
It's a first step actually, just this year, and I mean, yeah, we'll hope that we'll be able to expand that if there will be just an HPC advisor in Switzerland next year. I hope so. I cannot announce it yet, but that will be just also an opportunity to expand that and just trying to.
By the way, Hussein doesn't know yet, but he's going to share the
Okay.
There is one fundamental problem because in a logical program, building storage devices is faster than the offering.
Yeah.
Maybe we go closer to the data rather than trying to move it.
Yes, that's. Yeah, I mean, still, if you want to keep the data very close to each other, and you need, to protecting it from any physical disaster. I mean, you need to be far away from it, and moving it from one place to another is a problem. And this is one of CSCS problems actually in moving from Manno to Lugano, where we have to move 2.1 petabyte of data. And yesterday I had a discussion with, with experts from the factory of our hardware. Said, okay, what we are expecting to have, if we will switch off all our disk and bring it on again, how many we're expecting to lose? And that was a tough question, for them. And one comment was great comment came out from them saying that, that depends how much they were on for how long time. Because some experience came from a different vendor said that it was 5 to 10% they lost of disk from switching them off, moving them and bringing them on. So, I believe that was also different. That needs a different topic just to talk about for how we are going to physically move data. So tapes here could be a solution. Wow. Yeah, they are not dead.
Wow. They just aren't sexy.
Yeah. Thanks a lot. Yeah.